Hello world, it's your boy Alex the Coder, and it's time for you to imagine the situation. You just finished training an awesome movie recommendation ML system. You put it online, a free service, or maybe a paid API request. But how do you monitor it? How do you know how well it's doing and how much it's being used? And most importantly, how do you know if your ML model is down for some reason? For this exact scenario, there's a bunch of MLOps tools that let you monitor your models in production. Some of the most popular ones are Neptune, Grafana, and Amazon SageMaker. In this video, we're going to try out a new tool called Aporia, which is free to use and promises us an easy setup in only 5 minutes. Let's go over our experience with Aporia when we used it with our movie recommendation system in production and teach you how you can integrate it into your own production system. We'll also tell you about the strengths and limitations of the tool. If you like these videos, don't forget to like and subscribe. So, Aporia is an Israeli startup founded in 2019. It has a modern UI, is lightweight, and integrates in a plug-and-play model. Aporia allows us to monitor our model performance over time, as well as watch for anomalies in our data. As you can see, we can create monitors for prediction drift, data drift, missing value counts, and more with the touch of a button. Depending on your data, even more metrics could become available, such as F1 score. Alerts are already set up on all of the monitors, but we can customize them easily. For example, we can set up an alert for when the percentage of not a number predictions exceeds 80%. We can choose the level of importance associated with this alert, and Aporia will automatically monitor this for us. Alert notifications will appear on our dashboard and our email. We can see that we have one alert already from an alarm set up earlier due to an abnormal increase in requests. This occurred when we started to log data with Aporia. To get you started, let's show how we can log data with Aporia with an example Python script. Our use case was movie recommendations, but the Aporia API doesn't have any specific support for monitoring a list of movie outputs. Instead, we rethought the problem and decided to monitor the performance of our model when it comes to predicting the rating that a user would give a movie. We have created a stream of data using Kafka that gives us information whenever one of our customers in production rates a movie. And we compared this true rating with the output of a model trained to predict ratings to get an indirect signal of the quality of our system. Alright, here's the code. First, we need to set up a logger that will interface with Aporia. To do this, we choose an arbitrary name in APR model version, and we specify if we are using our model for regression, binary classification, multi-class classification, or multi-label classification. Then we must define a schema for the inputs and outputs of our model. They support a limited number of types for our schema, such as numeric, Boolean, string, and datetime. We can create an Aporia logger with our ID of our project by putting all of these parameters in. With the logger in place, now we just need to log our model inputs. In this example, we have a function createConsumer which generates data from production, and these data is the ratings that people give to movies. We can use this data to create a dict of similar structure to the featured schema that we made earlier, and a prediction dict which holds the predictions of our model. We can also create a dictionary which contains the actual values, since we know what the user rated the movie. This last step is optional, but it will improve the logging of our dashboard and allow us to measure the performance of our model. Let's go to the dashboard and see that in action. You can see that Aporia can use the actual values we gave it to report various metrics associated with our project, such as the root mean squared error. We can also see all of our logs at a per example level by navigating to another page. This data is also available in many different aggregated forms. For example, we can navigate to view histograms of our data and notice that all of our rating predictions are cluttered around 3 to 4.5, with a large bump at 3.5. This may suggest directions for improvement and possible bugs with our recommendation model. We've also set up a project to log the latency times of our production model in addition to the code we've shown you. On another window, we can view graphs of the min, max, and median of this data over time. The strengths of Aporia is in its user-friendly API and the ease with which users can set up monitoring and alerts for in-production metrics as well as visualize their data. Importantly, it's free to use and stores all the log data on its own servers, not adding to your overhead. It's a tool that can really shine when used with inference types that take in a wide range of features and do analysis. However, as we've seen, its API is not well suited to every problem. Aporia expects your data to be in the form of inputs, features, and outputs. And while this is the case for a lot of typical machine learning models, it doesn't hold for many others, such as our movie recommendation scenario. Furthermore, it's still quite new and doesn't have a lot of features which I would like to see, like time series analysis with standard deviation bars. It also seemed to have a bug with registering all our prediction data as being not a number, despite showing on another screen that it had registered not all entries were none. So this tool is a really good step in the direction of maintaining high data quality, and if it matures well, it can surely be a good tool for data analysis as engineering. A good sign of their commitment came from the head of product, Avishai Ganley, who reached out to us within 24 hours of creating our accounts to get feedback on the product. This shows that Aporia is working hard to incorporate user feedback, and by the time you use it, it could have drastically improved. Thank you for watching this video.